Welcome to another video lab of MrLopezClasses.com. We are going to continue in our course of marine air conditioning system, and this lab is in order to verify the components of a typical marine air conditioning system. Marine or residential or automotive at the end is the same. We are going to use some tools. We are going to use the multimeter, a good multimeter. We are going to use the clamp, and we are going to use the megometer. We are going to use the analog megometer or a digital. Any of those megometer is okay for this project. And we are going to check component by component, electrical components. We are going to start with the element, the most important element in the refrigeration cycle. You remember? That one, the compressor. Yes, we are going to check the compressor, and we are going to verify the electrical components of the compressor. Remember that the compressor have a thermal switch touching the case of the compressor and the motor relay or compressor relay. We are going to check both of them. The first one is the thermal switch. The thermal switch have two terminals. It's a normally closed switch. This is the cable with the power coming from the main breaker, AC breaker on the AC panel. Alright? If the temperature of the case of the compressor is good, is appropriate, that thermal switch should be closed. That thermal switch should be closed. What is the meaning of that? If I use my multimeter in the option ohms, in the option sound, beep, continuity, and we check in between both terminals of the switch, it's supposed that if the temperature is low, you have continuity. Beep. Of course, when you use the multimeter in ohms, the circuit should be off, no power. If not, you damage the multimeter. Alright? Turn off the main breaker coming from the AC panel, no power, and check continuity in the thermal switch. If the thermal switch at ambient temperature is open, this is the problem. The second element is the star relay or motor relay. You remember I explained in previous episode that relay have three terminals: common, star, and run. And we are going to use the same multimeter in ohms with no power on the system, and we are going to check the readings. And the first one is the reading in between common and star. We are going to copy that number. For example, this is 800. And we are going to check the reading in between common and run. 200 ohms. You copy. And after that, we are going to check the reading between star and run. 1000 ohms. Oh, this is good, because the reading in between common and star is equal to the reading in between common and run and common and star. This is the verification. Oh no, the equation is not good. The readings are out. This is an indication that the winding of the motor, the winding of the compressor is not good. I need use the megometer. I need use the megometer to verify that situation. Yes. Okay, we are going to use the megometer. Right now we have the star relay with the cables out, and we are going to check with the megometer. The megometer have two terminals, the positive and the negative. We are going to connect the negative into the case of the compressor, the case of the motor, and the positive in the terminal star S, or in the terminal R, run. Any of those. The first one in the star, and we are going to crank it. If the needle goes to 1000 ohms or more, infinite, is because the winding is in good condition. If the needle goes to 0, the winding is out, is open. If the needle stays in the middle, this is an indication that the compressor starts, but when you put more air condition, full air condition, maximum air condition, the compressor should die. In other words, it's not good. The needle should be pointed to 1000 ohms or more, infinite. 0 is not good. In the middle is not good. This is with the analog multimeter. You can use the digital multimeter, and it's exactly the same. The negative on the case of the motor, the positive in the terminal common or in the terminal start, and you select how much voltage you want to send, 1000, 500, 250, 500, okay, and you apply for 10 seconds, and after that the reading is 998, it's 1000 ohms, this is good. It's more than 1000, it's good. It's 200 ohms, it's pretty close to zero, that's not good. Right, you can use this, or you can use both to verify if the reading of this is okay. Nice. This is the compressor. With those readings, you check the condition of the compressor. You like it? Alright, this is the compressor. And before we continue, we are going to check the consumption in amps of the compressor. We are going to use the clamp, and we are going to select amps AC, that one. Alright, and we are going to hook the clamp in the cable coming from the breaker. That's the cable entering in the thermal switch. In that cable, and you start the air condition, and you see, you can read the consumption in amps at the peak, and after that at the operational temperature. And you copy. Oh, that reading should be according with the capacity of the breaker, the main breaker. If that reading is superior, it's not good because the breaker open. You like it? This is with the clamp. Now we are going to check the evaporator, the blower on the evaporator. The blower is a motor, normally single phase or double phase in some cases. Single phase with a capacitor. Okay, we are going to check the consumption of the hot line entering, and we are going to check the capacitor. Right now I am going to explain that procedure. And we are going to verify that if you spin the rotor of the blower with your hand, it's spinning free, no noise, no lateral play. This is an indication that that motor, the motor of the blower, is in good condition. Now we are going to check the control box. In the control box, normally we found two capacitors, run capacitor, start capacitor. Okay. We are going to check those capacitors. You remember in our course of electricity, the procedure to check those air conditioned capacitors?
In between 189 and 227 microfarads. In between 189 and 227. Okay. After I discharge the capacitor with a piece of wire in between those terminals, I can check. I select my multimeter in a capacitors. Let me explain the procedure. The voltmeter is off. Right now I go to this function. In this position there are two functions. The first one is for diodes, and the yellow one is for capacitors. Okay, I need the second one. I go over there, and now I press the yellow button, and I have the capacitors. Okay, and they say nanofarads. Okay, we are going to check how many farads I have here. And right now they have 205 microfarads. If you remember, this is 205. The capacity is in between 189 and 227, and I have 205. This capacitor is in good condition.
Yes, that's the procedure. It's nice, no? We need to use that procedure in different applications, in different models. With that procedure, you can check the capacitor of the blower. In some cases, the blower is coming with a capacitor, and you can check if the capacitor is good or not with that procedure. All right. Other motor that we have in a typical air conditioning system. Yes, the motor of the raw water pump. Okay, we are going to verify where is coming the power from the raw water pump. We are going to check with the clamp the consumption in amps of the raw water pump, and we are going to verify if the raw water pump is running properly. Okay, in other words, we are going to check in the control box where is located the output for power for blower, power for raw water pump, and we are going to verify where is located the terminal for the power coming in from the main breaker of the AC panel. And we are going to check where is the connection of the data cable from the thermostat. And where is the connection of the data cable from the sensor located in front of the air filter. Correct. We are going to analyze the control box carefully, in detail, in order to verify where are located each element. We are going to analyze where is located the triac. The triac. What is the input and what is the output? Yeah. If you are doing the laboratory by yourself, you can ask to me question at www.mrlopezclasses.com or info@mrlopezclasses.com. All right. That's the procedure. In what scenario you need to verify if the compressor is damaged or the blower, or it's depending on the question. What is the most common question in relation with the problems with air conditioning system? The most common question is, my air condition, I start the air condition, I select the temperature on the thermostat. I hear that a compressor start outside, evaporator start inside, the blower, but the air is warm. What is the first step in that particular case? Yes, with the pressure gauge, with the set of a pressure gauge, check the pressure on the system, low and high. Remember the chart? According with the refrigerant, those are the pressures recommended for that system. If the pressure is low in both sides, it's because you have a leak of refrigerant. If you have a leak of a refrigerant, what is the first step? No recover. Identify where is the leak and fix the leak. Okay, and of course, flush the refrigerant, vacuum on the system, and add it again. This is the next laboratory. Okay, all right. If you have a low pressure in both sides, it's because you have a leak. Okay, you fix the problem, you vacuum the system, you charge again the system, and once again you check the pressures. Both pressures are in the range. The system right now is working properly. This is the number one. Check the pressure on the system. And the second one is warm. The air is warm. Both of them start, but it's warm. The pressures are okay. The next one is verify if the cooling system in the condenser, the refrigeration in the condenser is good. In my boat, I need to verify if I have water coming out of the. This is an indication that the raw water is circulating. No raw water. Yeah, for that reason, the coil in the condenser, the temperature increase and the system stops suddenly for high temperature. You have a problem on the C strainer, or on the C cock, or on the raw water pump, or the system is blocked, clogged. You need to solve the problem and verify that the flow of water is good, and right now the system is ready. Yeah, that's the process. That's the process. Other common fault is my air conditioning system start, but 2 minutes later stop suddenly. This is probably, you remember the thermal switch on the case of the compressor? That thermal switch opened suddenly because overload, high temperature on the case. Yeah, you have a short, the winding of the compressor and the motor is not good. You need to verify with the measure. You need to verify that. Yeah, you have a high temperature because the raw water circulation is not good. Or in the evaporator, you have the air filter clogged, and because the air filter is clogged, the block of ice cover the evaporator, and the system stops for bad service. Yep. You need to identify where is the problem. Other common problem is, I hear that the compressor start, but work 1 minute and stop. Once again, 30 seconds off and start again. 30 seconds off and start again. Is cycling. This is an indication that the level of refrigerant is low, or humidity. What is the procedure to verify that? Once again, with the pressure gauge. in order to verify if you have low pressure of a refrigerant in the system. In that case, once again, identify where is the leak. I'm going to explain later the procedure. You need added the light on the system, the developer, and after that identify where is the leak, flush the system with the procedure to recover, vacuum the system, and charge the system again. This is the next coming episode. All right, those are the most common problem. Other common problem is my thermostat don't respond. Probably the batteries on the thermostat are out, or probably the signal coming from the evaporator in front of the filter, the sensor is out, or the cable is broken, the data cable is broken, and you need to fix those elements. We are going to talk later about troubleshooting, but this is the typical situation, and the electrical components of the air conditioning system is not complicated, and I want that you be familiarized with those components and with the use of the tools. I hope you enjoy this lab.